Okay, 24 wound players. Then after that, what happened? One third wound players are senior high, while the rest are junior high student. No student in the band plays more than one instrument. So two students from the cohort are randomly chosen. One of them is a senior high student, one of them is a junior high student, is half. Okay, so this is interesting. Okay, so I want to show this. What can I do if I want to find a senior high student? Okay, and players 10, that would win. Mm. Okay, so first, what I will do is I will draw something like this. Okay, go out like that, like that, like that. This is woodwind. This is brass. This is percussion. Okay, so out of the woodwind players is 24 over n plus 34. Brass would be n over n plus 34. Percussion would be 10 over n plus 34. Followed by woodwind. Woodwind, 1/3 will be SH. 2/3 will be JH. For the brass, 2 over 5 will be SH. 3 over 5 will be JH. I think do you draw a tree diagram for this?
No, I didn't really process the question.
So I mean, of course, the difficult part is to see which one is coming first lah in the tree diagram. Okay, because okay, so my thought is that if it's coming in stages, like I choose this, then I choose that, then I choose that. So it seems like there are a few stages. So what I do is I will do a tree diagram to process the information. There are many strategies. So one of it is like counting, just pure counting. One of it is tree diagram. One of it is possibility diagram. One of it is even Venn diagram. So there are times where you see in the questions, they also use that Venn diagram. So what I do is I see that there are a few stages. There's woodwind. First of all, there's the type of player. Then there's the category, the section of the player, whether it's in junior high section or the senior high section. So with that, then I'll use a tree diagram, right? So after which, right, okay, I'm selecting two students from the concert band. The probability that one is a senior high, one is a junior high would be half. Okay, so if I am selecting a senior high, right, what will it look like? Let me see. If I'm selecting a senior high, let me look back here. Okay, if I'm selecting a senior high, I'm selecting a junior high. What will it look like? Okay. So a senior high student. So let's say a senior high student. If I look at the total number of senior high, if I look at the total number of senior high student, if I want to select a senior high student, or I can also think of it this way. Okay, I'm not following the solution, but if I want to choose the probability of selecting a senior high student, right? This would be either 1/3 of 24 over n plus 34. Senior high would win 2 over 5. Senior high brass plus 4 over 5 senior high percussion, 34 plus n. Okay, then after that I will select a junior high. So if I select a senior high already, I will select a junior high. The thing is I do not know where am I selecting. Okay, so maybe what I can do is I look at the total number of senior high students then. Okay, so if I look at the total senior high students, right, the total senior high students, it will be 1/3 of 24 woodwind students plus 2 over 5 of brass students plus 4 over 5 of 10 students. This is the total SH. The total JH, right? Total JH students would be basically 2/3 of 24 students would win 3 over 5 of brass multiplied by 1 over 5 of 10 students. Is that okay with you?
Yep.
Can huh? So if I add them together, okay, I know the total students is 34, n plus 34. Total student count. The student count would be n plus 24 plus 10, which is equals to n plus 34 overall. Okay, so here I'm looking at this because I'm supposed to show this, right? And probably the next step, the only information that gives me is the senior high and junior high one. Okay. So for me to select a senior high, junior high, it can be either way. It can be SH followed by JH or JH followed by SH. That's why I need to multiply by 2. Is that okay? So it can be, so for me to select SH, okay, so this let me simplify this. This one will probably give me, total SH students will give me something like 8. This one is 8 plus 2 over 5n plus 8, which is the same as 16 plus 2 over 5n. For the JH student, 2/3 of 424 is 16 plus 1 over 5 of 10 plus 3 over 5n. This would be 18 plus 3 over 5n. Okay, so now I consider this total SH student, total JH student, right? Now, if I want to find the total, the probability of selecting SH student followed by JH, right? Selecting first SH student, right? It will be 16 plus 2 over 5n over the total number of students, which is n plus 34, followed by the second student, which is JH. Now, so the second student JH is 18 plus 3 over 5n over n plus 33. Why 33 is because the thing is there are one less student now, right? Because I've selected one SH student away. So I'm one less student. So the it's actually the same for JH followed by SH. So if I look at the probability of first a JH followed by second student and SH, right? It's actually the same. So it will be the other way around. It will be 18 plus 3 over 5n over n plus 34 multiplied by 16 plus 2 over 5n n plus 33. So if you look at both, right, both are actually the same. They have the same so-called numerators and denominators in just in different order, that's all. So far, okay? So
Yeah.
that's why I can just multiply. That's why you can see in the calculator here, they just multiply by 2. They just multiply by 2. They literally just multiply by 2 because these two, they are the same. They are the same. Okay? Right. So from here, right, then after which we equate this to half. Okay? So we equate this to half. So if I take 2 multiply by so-called 16 plus any of the fraction, 2 over 5n, n plus 34. Let me just make you a co-host in case you want to add anybody. 34 multiply by 18 plus 3 over 5n over n plus 33, right? This is equals to half. Okay? So this is where it will help us to form the quadratic equation. So we basically need to simplify this. So if I divide by 2 on both sides, I divide by 2 on both sides, that gives me 1/4 on the right. On the left, I have 16 plus 2 over 5n multiplied by 18 plus 3 over 5n over n plus 34, n plus 33 equals to half. Cross multiplying 16 plus 2 over 5n, 18 plus 3 over 5n multiplied by 4 is equals to n plus 34, n plus 33. I'll leave you the rest to you lah. So you need to simplify the equation. Okay, but it's doable. I mean, so end of the day, what do you get? You get n squared minus 5n minus 70, right? It will all be okay in the end. If it's not okay, it's not the end yet. Okay, so okay, so after that, you get n equals to negative 25 or n equals to 30. Now, definitely 25 will reject because here n refers to the number of brass players. Also, it cannot be a negative number. right? So with that, n equals to 30, that is the answer. Okay.
Yeah.
Okay, so next we will look at question 8. Question 8. Oh, this is a very good question. Okay,
Mm.
I believe you have seen this question a lot of times.
Yeah, in the practice two also have like a similar question.
Correct. Topic 3, practice set 1 also have. The AFL one also have. Yeah, and there's a good reason why we actually make videos for those lah. Okay. So hope you catch the hint. Okay, so here the polynomial of degree 3 or more has a factor of x minus 2. So when we say that this fx, right? Okay, here this information tells us, what does it tell us? Is that when by remainder theorem, right? If by remainder slash factor theorem, right? If we substitute x equals to 2, if I substitute x equals to 2, my answer will be 0. Right now, since by factor theorem, it says that, right, it is a factor. If x minus 2 is a factor, if x minus 2 is going to be a factor, right, then if I substitute 2 in, it is supposed to give me 0. There is no remainder. Right, so that's the algebraic meaning of it. You need to convert it into a currency that you can use. Okay, so then when I divide by x plus 6, the remainder is 8. What does it mean? It will mean that,
That means fx is -6, then it will give 8.
correct, and this is by precisely the remainder theorem. Okay, so with these two so-called information and tools, what do we do next, right? Is we now need to look at the division algorithm. What happens if my dividend now, fx, is going to be divided by x squared plus 4x minus 12, right? So remember that during lesson, I always say that we must know the division algorithm. Okay, dividend equals to quotient plus divisor, time divisor plus a remainder. Now, since right, this is the divisor, right? This is the divisor. And you can see that the divisor is a quadratic guy, right? What will you expect the remainder to look like? This is the quotient, but I don't know what it is. This is the dividend, right? This is the dividend. So I'm just literally writing out the division algorithm. The remainder, what will it be like? Okay, so a quadratic divisor, right? Your remainder has to be possibly linear. It is possibly linear. Am I right? It is possibly linear because if it's a linear divisor, constant. Quadratic divisor, it linear. So that's the first thing that you must know. Okay, that's the first thing that you must know. For a quadratic divisor, okay, potentially gives you a linear remainder. It gives you a remainder because once we reach a linear remainder, we cannot continue. Okay, we cannot continue. So this same fx, right? This fx here and here and here, they are all the same fx. It's the same dividend. He has these three characteristics. Now, how do we draw the connection? How do we actually draw the connection between the first two hints provided to us in this question here is that actually,
Where plus 4x minus 12 can be factorized into x minus 2 times x plus 6.
correct, precisely, x minus 2, x plus 6. So that is the second most important step in the whole question. So once you know this, right, and you realize that this information allows you to substitute 2, right now. And if I substitute 2, this whole thing is supposed to give me 0, right? It's supposed to give me 0 plus a 2 plus b. Since I'm literally substituting x equals to 2 here, x equals to 2 here, x equals to 2 here, x equals to 2 here. And this x equals to 2 gives me 0. Oh, and the thing is, I also know that it is a factor, means that it tells me also it is equals to 0. So what am I doing here is I'm literally just using the information, the good information provided to me from the question. F of 2 is equals to 0. All right. Now over this part, I'm incorporating what I see in the linear remainder. It is over here. Right, it's over here. right? This whole thing, substitute is over here. Okay, so putting the two information together, it tells me that 2a plus b equals to 0. That is equation 1. Second step, I will can make your co-host. Okay, second step, make your co-host. Okay, so second information, of course, is to start in the second part. Okay, which is over here. Okay, f of -6 is equals to 8. So after I sub in f of -6, I also know that this is equals to 8. This whole portion again is going to give me 0, and it gives me -6a plus b equals to 8. That is equation 2. So far, okay?
Yeah.
So with these two information, I will then solve for my a and b. Solving this, right? Solve a and 1 and 2 simultaneously. Solve 1 and 2 simultaneously, right? This allows me to get a equals to -1, b equals to 2. And what does that provide me? Remember, the a and b here signifies the divisor. It signifies the remainder. So a equals to -1 and b equals to 2 represent the remainder. It represents the coefficients of the remainder. So it tells you that from here, therefore, the remainder is equals to -x plus 2. Okay, and with that, I'm done for this question.
Mr. Tan, how do you do question 3 for polynomials? Revision package.
Polynomial revision package.
Yeah.
Okay. Polynomial revision package. This one. Okay. Question 3. Okay.
Question 3 part 2.
Question 3 part 2. Topic 8 revision package. Question 3. Okay. Intersects the x and y axis at point A and B, respectively. Find in terms of K, the area of triangle AOB, where O is the origin. Okay, so you are able to do part 1. Am I right?
Yeah.
Oh, that's fantastic. Okay, part 1 is so difficult and you can do. Okay, that's very good. Okay, so I'm just going to copy the part 1 answer. Your fx is equals to x minus k, x squared minus x plus 1. Okay, so now I go to topic 8, revision package, question 3. Okay, so this one is done. All right, this one is done. Okay, so the graph of y equals to fx will intersect the x and y axis at point A and B. At point A and B. Okay, so the thing is, okay, if I'm interested to find A and B, right? I mean, basically point A, right? Point A, it is the x-intercept, right? Since it intersects the x-axis, right? So for this, right, what we can do is to find the x-intercept, we substitute y to be 0. Is that okay?
Yeah.
So it means that here, right, I'm literally substituting my fx to be 0. So if I equate this to 0, right, you will find that there is only one answer. Right now, it means that either x minus k equals to 0 or x squared minus x plus 1 equals to 0. Right here, I believe that there are no solution. Okay, very easy. Just go and calculate the discriminant or work out the quadratic formula. You will find that it doesn't work. There's no solution. All right. The discriminant is less than 0. Here, x is equals to k. So what does this tell you is this x equals to k, right, is the coordinate of point A. Okay, it's the coordinate of point A. Yeah, let me just 1 second. Let me just put you all as co-host so you all can admit people. Okay, so whoever is able to, just help me to admit people, okay? Can all? I made many people go sleep. Okay. Okay, so after that, then I will look at a point, the y-axis at point B. So point B, right? If it says that it cut the y-axis at point B, so point B will be the intercept. So very simply, what will we do? We will substitute x equals to 0 to find the y-intercept. Right now, that is the strategy, right? That's the strategy here. Okay, that's a strategy. So I sub x equals to 0 over here. This is my equation, right? And I substitute x equals to 0 here. Okay, so I sub x equals to 0. I sub x equals to 0. F of 0 would be 0 minus k, 0 square minus 0 plus 1, which is negative k multiplied by 1, and that gives me negative k. Okay, so the y value is negative k. So using these two information, it will tell you that your point B is 0, negative k. That is the coordinates of point B. Is that okay? Can I? Where's Nisha? Okay, can I? Okay. So after that, you know that k is a positive constant. No, even so, just by absorbing this information, okay, you can sort of draw it out. I can sort of draw it out. Okay, so yeah, I can show you. I draw it out, right? And I'm supposing it looks something like that. Okay, so this is like my y-axis. This is like my x-axis. A k comma 0, right, will probably look, k comma 0 will be somewhere here. Right now, so I'm just guessing a k comma 0 somewhere here. The origin O is somewhere here, which is 0 comma 0, right? 0 comma negative k, I'm guessing is somewhere here, is below. Right, it's probably somewhere here. 0 comma negative k is probably my point B, right? So the triangle that we are looking at will look something like that. Okay, it will look something like that. It will look something like this. Right, this is your triangle AOB. This would be your triangle AOB. So very simple, it's a right angle triangle after all. Since one is the x-intercept and one is the y-intercept, from here, half times base times height. Okay? So to find the area of triangle AOB, you just take half times base, which is k units, times height, which is also k units. That is k square over 2 unit square. Right? Because if I look at this triangle, this is k unit, right? If I look at this, this is also k unit, right? That's basically the area, the height and the base. Okay? Yeah, so that is for question 3, part 2.
Okay, thank you.
Wait, Mr. Tan, what about quiz 2 time practice 2 question 5 part B?
Part B, just give me a while. Let me get it from my phone. Okay. Quiz 2, time practice 2, question something part B.
Question 5 part B.
Quiz 2, time practice 2, question 5 part B. Quiz 2, time practice 2, question 5 part B. Quiz 2, time practice 2. Okay, how do I add the page? Quiz 2, time practice 2. Quiz 2, time practice 2, question 5 part B. Quiz 2, time practice 2, question 5 part B. The curve, okay, quiz 2, TP2, question 5 part B. So the curve here meets the graph y equals to log 1.5x at 2.1.14. It correct to 3 significant figure So I'm supposed to sketch the graph on the same diagram and label the points of intersection clearly. Okay, can. So 0.2, 1.5x. Okay, 1.5x, right? Okay, basically this here, right? If you're looking at your notes, right, you should be looking at the case of k times a to the power of x, right? Where your a is more than 1 and your k is more than 0. Okay, so if I'm not wrong, the graph is increasing. It's actually exponential. It's actually exponential. So y equals to 0.2 multiplied by 1.5 power x will be climbing upwards. Okay. Now log 1.5x, right? Again, this is the case of, if you're looking at your notes, it's the case of y equals to log ax, where a is more than 1, where your base is more than 1. Since 1.5 here, this is more than 1. Okay, this is more than 1. All right, so a log graph, right, is basically like the long graph. Remember, your right hand is like the line on your right hand, the bottom line on your right hand. Okay, so this graph, right, let me just use another color. Right, see, I'll use blue. So this graph here, it will look something like that. Okay, it will look something like this. Let me just draw the first, maybe let me draw the graph. Okay, what happened? How come nothing coming up? Okay, so this is the y and this is the x-axis. Okay, then recolor log 0.15x looks something like that. Okay, this is actually very similar to one of the question in your quiz 1. Okay, so from here, right, then after which, right, they says that they intersect. Okay, it says that they intersect. So they intersect at the first point and the second point. I'm guessing that this point here would be over here, right? The first point, definitely, because I purposely draw 2 points because I saw the first one, right? So it's over here. This is the point, which is 1.14, 0.317, right? And this point over here, this will be the point 8.00, 5.13. Is that okay?
Yeah.
Okay, so after which, right, then they say that, okay, now hence we are supposed to solve the inequality of having 0.5, 1.5 power x, which is this graph over here, to be more than log 1.5x, which is over here. This is very similar to one of the questions in the topical revision package. So what you are doing is, if you are comparing this to this, right, if you are comparing, right, that means you must say that this graph, right, the y value, right, the y value of 0.2, 1.5x must be above this one, must be above the y value here. The y value on the left must be the y value on be greater than the y value on the right.
Oh, wait.
So
Oh,
is it okay?
yeah.
Yeah. Okay. So where will my left hand side, my blue graph be more than my green graph? Yeah, I'm using blue and green because I don't want to read the whole thing out. 0.2, 1.5 power x, then by the time we finish, you'll be okay. So I want my blue graph to be more than green graph.
Is
Right?
the part after the point of intersection of 8.00 and 5.13?
Very good. Yeah, so it's actually this portion. So you can see that the answer is basically either x to be more than 8.00 or you want x to be less than 1.14. Is that okay?
Yeah.
That will be the part that will solve your inequality.
Okay.
Okay. Today business very good. Wow. A few days I so lonely.
Mr. Tan, would you be able to go through revision package topic 5 and 6, question 12?
Topic 5 and 6, question 12.
Yeah, like the whole thing.
Just give me 1 second. Every single question.
Except for the last one.
Don't worry, don't worry. Okay, whatever ask me to do, I'll do. Okay. So okay, can. So let's go to, okay, so I start from 12A. So children, those who just joined, this is basically topic 5 revision package, question 12. Okay, so first, let me write down. Okay. Just now what did I go through? Yeah, shit, 我忘记了. Time prep 2. Just now what did I go through? Captain asked, oh, I wrote here. Please 2 time prep 2 question 5D. Now I'm just writing down so that I can put the YouTube link. Okay. Time prep 2 question 5B. Okay. Okay, so question 12A. First of all, I look at question 12A. What do I do is I'll probably log both sides, or I log both sides up, because I see that, you know, my power is a variable. So it naturally has this occurrence that, you know, if my power is a variable, right? So remember, I asked you all during lesson, logging both sides or logging both sides precisely is useful when your power is a variable, right? Your power is a variable. So over on here, 12A, what I'm going to do is I'm just going to log both sides straight away. Okay, I'm going to log both sides. So I log both sides. I log 1/5, right, to the power of 2 minus x. Logging both sides doesn't change anything, right? Because when I log both sides, right, my base is still more than 1. Okay, so inequality sign doesn't change. However, do take note that log 1/5 is negative. Log 1/5 is negative. Okay, okay, so from here, I can bring 2 minus x down. 2 minus x by the power law, multiply by ln 1/5 less than equals to ln 4/13. So before I go on any further, I just want to remind you that this is negative. And this is also negative. Is that okay? Can I? Can, yeah? Okay, so that means that when I'm going to divide both sides, right, by negative, when I divide both sides by ln 1/5, if I'm going to divide both sides by ln 1/5, what will happen to the inequality sign is you will notice that it will switch, right? Because I'm dividing by ln 1/5, which is a positive number. Okay? Can So this will be ln 4/13 divided by ln 1/5. Let me grab my calculator. A second. 0.73233. 0.732339525. Okay, so then after which 2 minus x. Okay, so I push x over to the right. This is the same as 2 minus 0.7323395. X should be less than equals to 1.272368 feet. Can? Okay, so that's for 12A. Okay, so actually 12B, 12C, 12 is all almost the same strategy. Yeah, okay, so next I will go on to 12B. 12B, right? Same. I see a power. What will I do? I will just basically ln both sides. Somewhere I see an E, right? So I'm going to ln both sides. Ln E to the power of 2x plus 1 less than equals to ln half power x. Okay? After which I bring by the power law, I'm going to bring 2x plus 1 down. I'm going to bring x down. Okay, so from here, this is 2x plus 1 multiplied by ln E. Ln E effectively is just 1, right? So I can multiply by ln E. But ln E effectively is just a value of 1 less than equals to x ln half. Ln half, nothing changes. Okay, but do pay special note again that ln half is negative. Okay, so whenever you ln both sides, you will find that, just remember, there are some guys which are very negative, ln especially, ln of any value less than 1. Okay, so the next part just remains to solve an equation, which I will then group my x terms. All right, I will try to push all the terms with x, push all x terms to one side. I will try to push all x terms to one side, just like how you solve a linear equation. I have 2x plus 1. Give me a second. Minus x ln half plus 1 less than equals to 0. So this guy has migrated to the left. X factorized 2 minus ln half is less than equals to negative half. X therefore would be less than equals to negative 1 divided by 2 minus ln half. Okay, and this answer would just be negative 0.371. So therefore, my final answer is x less than equals to negative 0.371, correct to 3 sig fig. Okay? Okay, all? Okay, so next one I will go through is 2C. 2C. Okay, 2C is, am I able to copy like that? Oh, can. Okay. Hey, shucks. Okay, so 2C. Okay. So once again, for those who just joined us, this is revision package. Topic 5, revision package, question 12. So now I'm going to 12C. 12C here, I just make 2 log as a subject. So if I push 2 log 3x minus 3, perhaps if I do this, I just bring my 2 over to the right-hand side, subtract both sides by minus 2, so by 2, I get negative 6. Divide both sides by negative 2. Divide both sides by negative 2. I will get 3 on the left, log base 3x minus 3 on the left, okay, and 3 on the right, and the inequality sign switches, right? So just take note the inequality sign switch. All because we are dividing by a negative number, okay? This one will switch because dividing by negative number. Okay, now after which, do like what you do. Remember the woodcutter story, right? Change the log form to index form. My fastest way is just to change from log form to index form. So remember what I told you all for lessons, right? As long as base is more than 1, the sign stays. The sign stays. Okay, meaning don't worry about the sign switching side. The sign stays. So from here, x minus 3 will be less than equals to 3 power 3. Okay, meaning what am I doing here? I'm switching the 3 over to the left-hand side. Okay, then from here, x will be less than equals to 3 plus 3 power 3. The final answer turns out to be 30. So x is less than equals to 30. Okay, so of course, when we do this, right, and you do log, right, once you see log, I will just be a bit careful because I know, remember in class, I told you before that log, surds, indices, they are like our best friends, right? So when you bring your best friend out, if you know that your best friend don't like bubble tea, then you will not bring them for bubble tea. Okay, so x minus 3, for example, just take note that this part here has to be positive. Okay, so in my notes, I also will write down, and x minus 3 must be more than 0, which says that x must be more than 3. Right? So incorporating this x more than 3 and the information that x is less than equals to 30, it will tell me that x must be between 3 and 30. And that is my final answer. Okay, that's my final answer. Okay, for 12C. Okay, so for 12D, 12D actually is very easy. I've gone through it in one of the earlier videos, I believe. Okay, so 12D, right? Yeah, it's very easy. Okay, so this one, right, is a scammer. Okay, can I say that this is the same as log x to the power -1? Can I say that this is the same as negative log xx? So Nihao, what is log xx? Is the same as?
1.
Correct. So actually this whole thing, right, is just -1. Once I change to this, I think you know what to do it. Okay, that will make the whole thing so much simpler. Right? You're not looking at so many x. There's actually only one guy. There's only one x. Okay? Can I? Okay, so let me just make more of you the co-host in case got anybody come in. You all can just I actually open it to the other teachers. So it's like literally open to the whole cohort. Yeah, whoever wants to come can come.
Mr. Tan, how to do topic polynomials trying to use comparing of coefficient method?
Topic 8 polynomials. Topic 8 polynomials. 8 revision package, is it? Or
No, I'm not asking a question for this one. I'm just asking how to do the trying using the comparing of coefficient method.
okay. In general, like in general. Okay, so what you do is you personally, right, I will recommend that you do both. You use both substitution and you use both comparing coefficient. Okay, I suggest that you use both. Okay, maybe let me find a question. Okay, for example, let's say 3x cubed minus 7x squared plus 8x plus 4. Okay, also here we are talking about Pierce's question, right, which is to compare coefficients, right? There are ways to find unknowns. Either we compare coefficient or we do a substitution. So sometimes, right, you will find yourself that, Pierce, in whether you're doing a partial fraction or you're doing remainder factor theorem, you sometimes find yourself in this situation where you may have something like this, right? You may have something like this, right? So maybe it's like a bx, okay, ax square plus maybe bx square plus cx plus d, something like that. Okay, plus cx square plus b x minus 2 x plus minus 5 plus cx minus 5 x plus 1, some sort. Okay, so from here, okay, first of all, if I compare coefficient, I generally tell my students that comparing coefficients, right, it is easiest for the highest and the lowest power. It is easiest for the highest and the lowest power. Okay, so in this case, for example, if you look at the left hand side, right, you see x cubed, right? So what I'll do is I'll compare. I like to personally compare for x cubed. Okay, so I compare, for example, coefficient of x cubed. I find the one that gives me the fastest reward. My left hand side is 3. What's my right hand side? My right hand side, right, I want to ask you, okay, does this one give you any x cubed? No. Does this one give you any x cubed? No. What about this one? You see, there is a ax squared. Ax. So I can straight away tell you a equals to 3. Okay, no? Because when we compare on both sides, your x cubed and my x cubed must match. Your x squared and my x squared must match. Right? You have this boat, I will have this boat. You have a center, I have a center. You have a point guard, I must have a point guard also. Okay? Yeah. You have a dancer, I must also have a dancer. So we must match 1 for 1. Okay, so then next, right, I will do substitution. So substitution, right, you need to observe very carefully the factors that you sub, right? It will help you to get rid of many terms. Okay, so like for example, here, you see, when I see this, right, I know that I see this x minus 2 appearing, right? I know that if I sub x equals to 2, right, these 2 will pass away. I can find c. Okay, now, also, if I see x minus 5 here, right now, if I sub x equals to 5, these 2 will pass away. Then I can find my a also. Right? So that's how I mix my comparing coefficient and substitution together. Okay, you cannot do purely one method because that will make things very difficult. Okay?
But what if you don't simplify but use the C to substitute?
What if I don't? I just purely substitute, huh?
Yeah.
it will not work all the time. It will not work perfectly also. It will not work perfectly also. Okay, it will not work perfectly also. You will end up that, not say you cannot do, just that your algebraic manipulation must be damn solid because you will find yourself in a situation where you have simultaneous equation. That is actually more time consuming. The faster students I know, right, they always mix both methods one. Sometimes they suck, sometimes they compare, right? But they plan first before they start. Can? Okay, so let me go on to the chat. I think I saw some students ask some question. Okay, first, okay, Mabel asked for question 13 and 14 of revision package. Okay, so I think this is, oh, what am I doing? Okay, so this is topic 5, revision package, question 13. Question 13. Okay, so shout out to Mabel. If any of you are here, you do pay attention as well. Okay, so question 13, let me just take a photo. Just hang in there and stay motivated, okay? Yeah, these few weeks will pass by very soon. Okay, so this is question 13. Okay, so here, right, okay, it's not that bad, it's not that bad, okay, it's not that bad. So it's not as scary as you think it is, okay, very, very beautiful and nicely located question. So one thing, of course, I noticed is that e power x is here. Okay, I'm sure you know that, okay, maybe e power x, right? If I factorize out, it can look something like this, which is e power x log 5, 3x minus 5, plus log 5x less than 0. I see a lot of opportunities here. First, this guy, right, e power x is more than 0 for all x. Right, it's never going to give me any solution. It's always positive graph. So just look at your right hand. Remember your right hand top line? That's where e power x is, right? So remember, I always ask you all in class, right? E power x is this line. E power x is this line. It's your right hand line. E power x is the top line, and log ax is the bottom line. Okay, so this is e power x. So if you recall this e power x graph, right? The graph looks like that. Y equals to e power x. All the y values, right, are always positive one. The y is more than 0 all the time, right? All the time. So what does it say? Hey, what happened? My screen hang. Oh,糟糕. Why does it stop at my hand? Is it my screen hang? Are you looking at my hand now? You cannot see anything. Yeah, I went back already. Oh no. Let me stop my. What's happening? Yeah, we can't see. Okay. What does it happen? Okay. Okay, so I believe I should. Okay, can. So basically this part, right, no solution. So I can so-called divide both sides by e power x. I divide both sides by e power x. Right, because it doesn't give me anything. It doesn't give me nuts or anything. No solution. It doesn't even give me any intercept. So I'm just looking at log 5, 3x minus 5, multiply by log 5x. Multiply by x to be less than 0. So the reason is because I can also at the same time I apply the product law. I can apply the product law of logarithms, right? Log A plus log B is log A times B. Over here, I can change the log form to index form. I can change my log form to index form. Right, so over here, 5, this says that 3x multiplied by 3x minus 5 is less than 5 power 0. I'm just changing log form to index form. Okay, so as long as the base is more than 1, right? You can see the base is more than 1, right? So don't worry, the inequality sign will not switch. Okay, 5 power 0 is just 1. So it's saying that 3x squared minus 5x is less than 1. Is therefore saying that 3x squared minus 5x minus 1 is less than 0. So, Mabel, I do until here. Will you know how to continue? Mabel, you there? Mabel, you want to say something? Hey, Mabel, why don't you just tell me? Okay. I ask you to unmute. Okay. Can Oh no, you're on camera, right? Better. Okay, like that. Question 13. Okay, so next one is question. Your mic spoil. Okay. Okay, can. Next one, question 14. Question 14. Question 14 I got do before. I think I got do in one of my earlier videos. I think it's in the very first consult. Okay, so question 14. Quick one. This is question 14 of the revision package. Topic 5. Revision package. Question 14. Okay. Given that the point intersection between log x. Okay, so this graph is familiar now. So we all know that the graph looks like that. This graph here, right? This is actually a linear line. It's actually a linear line. Okay, so I just want to write it out over here, right? So y equals to log. If it's possible, you all just shout to me, because I when I talking, I will try to I may not be able to read the messages, or I may not be able to read WhatsApp. So you all just, if you can, just use audio, shout to me, can? Yeah, you all don't or text me personally. Yeah, I'm a bit overwhelmed. Okay. Okay, so this is the same. If I x times log 0.5, then I plus 0.5 log 0.5. It looks something like that. So what I want to say is, can you all see that this is like y equals to mx plus c? So in a sense, right, this is actually a line where this is the gradient. This is the gradient m. This is actually the y-intercept c. Can you see that? Can. So that's how you all will appreciate this question. It can look very disgusting, full of log inside, but after all, deep within, it's just a simple line, which you have learned in set 1. Special note again, shout out, you know that log 0.5, it is a negative value, right? So it means that your line is downward sloping. So without further ado, I draw my line. I don't know how it looks like. I try my best. I forgot already. I did this a few days ago, and a few days later, I just forgot. Okay, so log 0.5, right, is downward sloping. 0.5 is also negative. Okay, so this graph will probably go something like this. Okay. The y-intercept is also negative, and then it's downward sloping, so it goes something like that. Oh, sucks. Okay, something like that. Yeah, something like this. Okay, so this is the graph. Okay, this is like 0.5 log 0.5, and this is the line y equals to x log 0.5 plus 0.5 log 0.5. So I've drawn the first graph. The second graph, log x, right, will look like this lah. Okay, let me use a different color, blue color. Oh shucks. Okay, so it will look something like that. Let me just draw it out a bit. My graph may not look so nice. Let me do my best. This is y equals to log x. Okay. So the point of intersection, right? The point of intersection here, okay, is over here. This part here is 0.5 log 0.5. Okay. This is what the graph look like. Remember, for log graphs, it has a vertical asymptote. So do draw the vertical asymptotes. Draw your intercepts, 1, 0. Draw this one. I forgot. I'm not sure what is this. Let me just go and find the answer to play cheat a bit. A 14, right? negative half. This is negative 0.5, comma 0. All right. So then after which I'm supposed to solve the inequality. I'm supposed to solve this inequality. Now let me write down. Okay, so I've done the first part now, everybody. I'm going on to the second part. Now it looks like that now. Okay. Simple idea. Multiply both sides by log 0.5. Multiply both sides by log 0.5. Now, I also want you to note that log 0.5, as I have mentioned, and we have come across many times in today's session, it is a negative number. All right, it is a negative number. It is a negative number. Okay, so therefore, x log 0.5, the sign will switch, log x minus 0.5 log 0.5. All right, so take note here, the sign switches. The sign switches. Okay, the sign will switch. The sign switches because it is a log 0.5 is a negative number. Therefore, you see that the sign switch. Okay, now from here, add both sides by 0.5 log 0.5. Add both sides by 0.5 log 0.5. You have x log 0.5 on the left plus 0.5 log 0.5. The right hand side is just log x. So from here, what do you see? You see that these are the two original graphs. This is the original graph. The original graph that you draw. This is the original graph that you draw. Right now, you're just looking for areas where your linear line, right now, your linear line is under the curve. Right, so where is your linear line under the curve? It's perfectly this part here. Your line here is underneath the graph. Okay, over here, your line is underneath the log graph. So very simply, the answer is just x more than 0.5 from the graph. Is that okay? Can I? Sorry, who asked this question? Oh, I lost my... Who asked this question again? Check. Question 9 of topic, where am I spoil? Sorry, who asked this question? Is the person who asked this question okay?
Yeah, I asked the question.
Okay, can. This one, okay. Can. Okay, so let me just write down.
Mr. Tan, it's because I went to go and check the quiz 2 solution, right? Then the revision package solution. And after that, I saw that you need to still do the long division before using the normal partial fractions method.
Wait, what are you referring to? You're referring to
Question 9. I was the one who
okay.
posed the question. Yeah.
You give me a second. Give me a second. Let me just go down. Okay, so this is asked by Mabel. Mabel, topic 5 revision package, question 13. Mabel, are you okay with this? Mabel, okay? Mabel, yeah, okay, can. So after Mabel, the next one I see is question Erin, time prep 1, question 1, question 2. Time prep 2, wow, okay. Where, wow. Let me just take a photo first. I take a photo of the photo. Okay, time prep 2. Okay, topic 7, assignment. Wow, assignment. Now don't do assignment, I'm going to do the revision package. Question 9. So sorry to keep you all waiting. Okay, so we try our best. Okay, can also try not to rush. Okay, time prep 1, question 1. Question 1, 2, part 2. Time prep 1. Time prep 1, question 2, part 2. Time prep 1, question 2, part 2. Time prep 1, question 1, and question 2, part 2. Every question, time prep 1, question 1 also. Are you there? Oh, don't tell me your mic spoiled.
Yeah. Question 1.
Okay. This one, how? Is it okay? Yeah, okay.
Yeah.
Okay, so for, wow, my screen hang. Okay, just wait a while. I want to show that the line do not meet. So what I will do is I will put it together. I'll put them together. And then I'll show that the discriminant is less than 0. Okay? You can see my hands are here, but my screen very slow. So yeah, it's okay. Just give you a while. Okay. So I want to show that the line does not meet. So basically, right, when I equate these two, right, 2x minus 1 minus p squared over 2 is the same as x squared px plus 2. This is the same as I want to show that this one has no solution. Okay? Or aka discriminant less than 0. Right now. So if I want to show that the discriminant less than 0, I need to form it in the form of ax squared plus bx plus c. Can every? Okay, so everybody, this is time prep 1, question 1. Right, so from here, right, let me just push everybody together. Also, I'm going to change everyone to the left-hand side. Change everyone to the left-hand side. I have minus p plus 2x plus 9 plus 1 is 10 plus half p squared. And I'm going to group my constants together so that I can see that this is my constant, this is my b, and then this is my a. My a is equals to 1. So from here, right, so we will make it in this form before we can find discriminant now. Okay, now we will do the discriminant, and I want to show you that the discriminant is less than 0. So here, my discriminant is b squared minus 4ac, right? I try to simplify this. This is the same as p squared plus 4p plus 4 minus 40 minus 4 times half is 2p squared. If I simplify, this is the same as negative p squared plus 4p minus 36. If I try to complete the square, this is the same as negative p minus 2 square plus 4 minus 36, which is the same as negative p minus 2 square minus 32. So Erin, you see that this part, right, is already always less than 0. This somehow I minus. This is basically less than equals to negative 32, which is less than 0 for all x. For all p.
Why do you complete the square?
Why do I complete the square? So may I clarify the question again? Why is it? Why do I?
Yeah.
Because, okay. Okay. This one is hard. Okay, Erin, you listen very carefully. Okay, I got another way to do this. But you hear me out. Okay, so because I want to show that the discriminant is always negative. So by completing the square, right, I can establish the value of my discriminant. Right. So if you see something like this, right, you know that a square, a negative square is always, it cannot be positive. It's either 0 or less. That is why I complete the square. Right. So remember, this is what we want to show. From the start, right, our end point, right, is we want to show that our discriminant is less than 0. Is that okay? Can I, Erin, do you
So
like?
sorry.
You say first. Yeah.
So even if we want to show that it's more than 0, you still can complete the square also.
Yes. Example, if a discriminant, something like this, like p plus 2 square plus 7, this is always more than 0.
Oh, so like both parts of the complete the square has to be more than 0 to have two solutions.
Correct. Okay.
Okay. Thank
So-
you.
Okay, you hear me out. You hear me out. Okay, why I want to get your attention, because, and to everyone here, there is an easier way. If you know how to do, okay. You watched the movie called Inception before? Hey, Erin, I'm talking to you. Hey, nobody, sorry, because nobody on camera except Jing Kai, Pearson. See the rest all them on camera. You're not steady. Okay, so okay, Erin, are you there? Okay, so
Yeah.
I want to ask you, okay, do you like completing the square?
No.
Okay, I'll show you another way, can?
Okay.
So you listen. Okay, remember what was our goal? Can you remind me again, what was our goal? What do we want to show?
That discriminant is less than 0.
Okay, so now, right, basically, you want to show discriminant is always less than 0, right? AKA, you want to show that this guy, the discriminant is negative p squared plus 4p minus 36 is always negative, right? For all p, am I right? Am I right? Look at the line. Okay, so now I'm going to tell you something. It may sound a bit ridiculous, huh? What you can do is you calculate the discriminant of the discriminant. Okay, you calculate the discriminant. Okay, so now you take this one, right? Okay, let me call it D1. You calculate the discriminant of the discriminant. The discriminant of the discriminant is b squared minus 4ac. Can you see that this is 16 minus 144 or something like that, which is negative 128, which is less than 0. At the same time, you can also see that coefficient of p squared is less than 0. From these two, right, you can conclude that your D1, which is negative p squared plus 4p minus 36, is always negative. Is always negative. Okay, that's why I call inception, like you dream in a dream. This one is you're calculating the discriminant of the discriminant. The concept is that we are proving, if you want to prove that this discriminant is always negative, we can treat it like a function and find a discriminant of this discriminant.
Does this work for all? Like even more than 0 or equals to 0?
That's right.
Okay.
Yeah. If you can understand this method, what's the plus point? You don't need to complete square. Okay? Can okay. So next, I will go on to question 2. Okay, so I'm just checking. This is time prep 1, question 1. Okay, next 2. Okay, so 2 is it the entire part? No, I remember it's not the entire part. It's the 2 part 2.
Part 2. Yeah.
Okay, so time prep 2, part 2. Okay, so from here, I'm supposed to find the range of values for k. Okay, so the first part it is like this one. Okay, so I think the answer you got is k less than equals to 1 or k more than equals to 5. So I want to share with you the graph actually looks something like this one. Okay, so the graph actually looks something like this one. So y equals to x squared, just to prove, to give you a context, right? You will learn how to draw this graph in senior high. It looks something like this one. Okay, the graph looks something like this one. This is the graph that we are talking about. This graph that we're talking about, it looks like that. Okay, so the maximum point, right, over here, right, actually is something, then the y value is 1. The minimum point here is something, the y value actually is 1. So you will notice that if I draw a lot of lines, no matter what lines I draw, if I draw, as long as I draw y equals to k, right, like y equals to k, where so-called k is, sorry, this is 5, where k is more than 5. So example, if I draw y equals to 5, yes, it will meet. Okay, if I draw y equals to 6, it will meet. If I draw y equals to 1, it will meet. If I draw y equals to -0, it will meet. Okay, so that's what I mean. So as long as my k, right, as long as my k is between 1 or 5, the line, the horizontal line is going to be, I'm going to be damn sure it will meet the curve. Okay, so what does it mean? If it meets, right, part 2 is basically the opposite of part 1. Right, so if my lines are going to be in this region, y equals to 4, it will not meet. Y equals to 3, it will not meet. Y equals to 2, it will not meet. Y equals to 1.9, it will not meet. So what am I saying here is in this no man's land, where your y is between 1 and 5, right? The line will not touch the blue curve. The line will not touch the blue curve. That's why you see part 1 is so pathetic. They only give 1 mark because it is a hands question. The answer is just k between 5 and 1. That is all. Sorry, they say y, so y between 1 and 5. That's all. Okay.
Yeah, thank you.
Okay, so next one. I will go on to question. Okay, so time prep 2, question 4B. Next one is what? Time prep 2, question 4B. 4B, 7, and 8.
So Mr. Tan, I don't need question 2 already.
Okay,
Because same as the previous one.
question 4,
Yeah.
this one. So this is actually very similar to the revision package topic. Looks so close. Okay, so this is time prep 2, question 4. Okay, so 4A and 4B both?
No, just 4B.
That's 4B. Okay, question 4B. Let me just write it down. Okay, so from here, x ln x. So what I can do is I realize that I can actually factorize out my ln x. Okay, my x less than more than 0. Okay, the thing is this. Okay, if I have to, the fact is this part, right? Remember, ln is like your favorite friend. The thing is, whatever is inside the ln has to be positive, right now. So when you're solving this, right, it also tells you that your negative x must be more than 0. Okay, because it is inside the ln. It's inside the ln. Okay, so here, if you incorporate this, you know that x must be less than 0. If x must be less than 0, it will tell you that your ln negative x minus 1 must be less than 0 as well. Okay, therefore, ln of negative x less than 1, negative x change to index form is less than e power 1, x is more than negative e. Okay, so the information here that you need to absorb is this part. X must be less than 0 because of this guy. Okay, otherwise your ln negative x cannot be defined.
Wait, why is negative x more than 0?
Because it's part of logarithm. Logarithm, remember, they can only take in a positive diet.
Oh, okay.
Okay. So with that, that tells you that your x must be negative. Therefore, this must be a negative as well. Negative times negative is positive. Okay. So then I will incorporate these two answers. the intersection of both answers will have me putting x to be more than negative e at less than 0. That is my final answer. Okay. Can I? Okay. Okay, so I'll go on to the next one. Next one is question 7. Okay, question 7. Question 7. Okay, so question 7, this is time prep 2, question 7. TP2, question 7. Okay, determine, okay, 7 from the start or 7A or 7B or?
7, yeah, from the start.
From the start. Given that this is a quadratic expression, determine the range of values of m such that it's always positive. So this is the one where I'm going to do discriminant. Okay, so when I say that something is always positive, right? Always positive means that, first of all, you must note that it must be a happy face. Okay, it must be a happy face. So it will tell you that basically discriminant is less than 0 and the coefficient of x squared must be more than 0. Okay, that's the important information that you must take in. Okay, so from here, right, you see here, okay, so first I find a discriminant. The discriminant is b squared minus 4a c, right, which is the same as 4m squared minus 8m minus 12, correct? You want this to be less than 0, right? You want this to be less than 0. This will imply that 4 of, you factorize m plus 1, m minus 3 less than 0, negative 1 less than m less than 3. But at the same time, remember, it's a happy face, so you need the coefficient of x squared to be more than 0. Therefore, m must be more than negative 1.5. Now, take the intersection of both. The answer will turn out to be still negative 1, m and 3. Okay, that is the first part of question 7. Is that okay?
Yeah.
Can I? Okay, so now I will go on to A. If you're ready, I'll go on to A. Now, A, right, if you observe, it's a hence or otherwise, and it is always negative. Always negative just tells you two things. Discriminant is less than 0, and the coefficient of x squared has to be negative. Okay, it tells you that. Okay, so coefficient of x squared negative is what? It's very similar to the first part because you can actually use the answer from A. Where discriminant less than 0, right, is basically this. So B, for B, right, if you need discriminant less than 0, that tells you that like m is between negative 1 and 3. Now, if you need coefficient of x squared to be less than 0, that tells you that in reverse, m must be less than negative 1.5. Correct? So if I take the intersection of these two, right, I want my answer to fulfill m between negative 1.3 and less than negative 1.5. There's no answer. There's no intersection that can fulfill this. Okay, there's no answer. Just think of the number line, right? So 1 is negative 1 to 3. Right now, 1 is you need m to be negative 1 to 3. The other one is you need m to be less than negative 1.5. There is no intersection. Right now, if I need to fulfill both conditions, I can't. Right? There's no m value that can fulfill this. So the answer is there is no such value. No such values of m. There are no such values of m. Is that okay?
Yeah.
Okay, so next one, B. For it to have real roots, right? Simple, right? So for it to have real roots, right? We have to ensure, we must ensure that it must first be quadratic. That means the coefficient of x square must not be equal to 0 lah. And your discriminant must be more than equal 0. Okay, so discriminant more than equal to 0, it basically is the opposite of this. It's the opposite of this. Right? So with discriminant more than 0, right? You need to consider, this will tell you that your m must be either more than equals to 3 or m less than equals to -1. Not equals to 0 will tell you that 2m plus 3 must not be equals to 0. M cannot be -1.5. These two will be your answer, or B.
Wait, I'm so sorry. Can I check how do you get 1.5?
1.5, right? For B or C?
B.
B, yeah. Okay, it's because 2m plus 3 is the coefficient of x squared. This has to be negative. This has to be negative because we are saying that it is always negative, right? Discriminant less than 0, coefficient of x squared must be less than 0 as well. It must be a set phase.
So whenever it's always negative, is a set phase.
Yes. A positive graph cannot be always negative, because you think about it, Erin. If I give you something like this, right, a happy phase, right, where the coefficient of x squared is positive, right, one day it's going to be positive. It cannot be always negative one. Only a set phase can be always negative.
Okay.
Okay. So next I go on to, yeah.
I have a question. That's a general question about polynomials. With polynomials, right? How it's easier, like when you wanna use using the comparative coefficient method or using the substitution method, right? You should like factorize it first, right?
I should factorize it first. Yes. But actually, it won't be something that you have to deliberately do. Most of the time, due to partial fraction, due to your working, you will start with something that's already factorized.
Yeah, I'm just saying, like, if it's not, then let's say the fraction cannot be factorized. Will you give a question like that?
The question cannot be factorized, meaning,
like it doesn't give you a straight answer in the calculator.
yes, you can have questions like that. You can have questions like that.
Aiyo,
Yeah.
then
So it's not factorizable. It's not factorizable. But let me see. What do you mean by this? So yeah. I mean, but you don't have to do substitute. I mean, you can still compare coefficient to do one. Even if not factorizable, still can do.
so how do you compare coefficient without how do you compare the coefficient without factorizing?
Without factorizing. You have a question? You have an example?
I don't have it.
Okay, I'm just off my head. I'm just thinking of something like that. Okay, is that factorizable in the sense that you definitely can come up with a linear factor? Okay, but not a quadratic factor. But not okay. So, let me give you an example. Okay, so example, if I give you a cubic, right? A cubic guy can look like that. X minus 2, x minus 3. A cubic guy can also look like this. X squared plus x plus 1. You can see that this is fully factorizable. It is fully factorized, but this one not factorizable. Okay, ma? But you can still find the unknown coefficient. Means if I equate this to ax cubed plus bx squared plus cx plus d, you can still find. Just by comparing or just by substitution, you can still find one.
Then for the non-factorizable equation, that one, right? How do you see the coefficient of the x cubed?
Okay, so for example here, right? Compare x must multiply with x squared to give you x cubed. So I compare this, right? if I compare coefficient of x cubed, I can see that a equals to 1. Cannot? So if I want to compare x squared, I can also see this. X must multiply with x. So that is 1x. Negative must multiply with x squared. That's 1. 1 minus 1. Then it tells you equals to b. B equals to 0. Yeah, so I can say that this is equals to 1x cubed plus 0x squared. Slowly, lah. Just look at the rainbows that can give you the x squared and x. Oh, yeah, can I? Okay. So next one, time prep 2, question 8. Time prep 2, question 7, I do already. Time prep 2, question 8.
It's just question 8, part 5.
Part 5. Okay, time prep 2, question 8, part 5. Part 5. Oh, so cute. This one got dinosaur. Okay, so I play a stuffed dinosaur. So I play. Okay. When I draw, this one very need to digest. Give me a while. Okay. A game is played where the player also draw 2 balls. A red ball, I spin a wheel to a wish. Now play 2 tokens to find the, except probably that he wins stuff, 1 stuff dinosaur. Let me look at the answer. Part 5, right? Okay, so when you look at, okay, I'm going to borrow answers from earlier. Part 4b, you know that the answer is 2/11, huh? Okay, huh? So if I'm going to play the game twice and I want to win 1 stuffed dinosaur, right? It can mean that, okay, the first game I win, the second game I lose, or the first game I lose, the second game I win. Yeah, and that's the answer. Just add these 2 up. Or basically, you can just times 2 because all 4 components of the multiplication are the same.
Wait, why do you times 9/11?
Okay, because if I win 1 stuffed dinosaur, right? In the second game, I cannot win again. I must lose. So I take the complementary.
Why you cannot win another time?
Because he says that he wins 1 stuffed. He never says.
Oh,
So when you say you win 1, right? You must consider that the second game you must lose.
okay.
You know, it's like now you buy this ticket, then tomorrow you cannot buy again. One-time membership only. Okay. Yeah. Okay. Okay. So next one, maybe just let me look at other questions first. Okay. So let me help other people as well. Okay. So next let's look at question 9 of revision package. Question 9 of topic 8 revision package. Question 9 of So Aiden's question. Topic 9 of the revision package. Topic 9. Topic 9 question. Topic 8 question 9. No, what am I looking? Question 9 of topic 8 revision package. Is there a question 9? 好像没有嘞。
wait.
Is it question 8? Is it? Do you mean question 8? Question 9 of
No, there is question 9. Question 9, 10, 11 is a partial fraction question.
yeah, how come I only have until question 8?
Wait, this is the solutions, right? Yeah, there is the solution, but I don't think that's the question.
Question. So the question is not there, huh? So how you did the work without the question?
No, the
Soft copy one is not there.
the physical copy of it has the question, but after that, the online answer copy doesn't have the question.
Okay. I understand. Thank you for helping me.
Yeah, but my question is, why do you need to use? It's like similar to question 11. Why do you still need to use the long division before doing the normal partial fractions method?
Okay, do you remember in class, right? Okay, I have said this before. partial fraction, right, before you start, you have to first make sure that it's a proper fraction. If it's not proper, you cannot start. The answer will be wrong. You will not get what you want. You have to first make sure that it's proper. Okay, so that's why if I look at this, right, you can see that this is not proper because on top cubic, on top is the degree 3, below is degree 2, which if you note that if you see the topic 8 part 6 notes, right, the first part talks about improper and proper. You have to first do long division. Okay, maybe
also as long as like the numerator, numerator, the degree is less
less
less than the
than
denominator, then is a proper fraction.
correct.
Okay.
So just be very, very careful. Okay, be
Thank
very,
you.
very careful. Don't jump in too quick or apply your partial fraction too quick because it can be improper. It can be improper. So the learning point that will best bring this out is question 6.4 of your notes. Okay? Can Is it okay?
Yeah.
Okay, so after Aiden, who else?
Wait, Mr. Tan, for could you also like squeeze in question 11 of that one? Because I tried to do it, but after that, like there was like some problem with it.
Just give me a second. Esther, you also asked this question, right?
Wait, how do you get like 2x plus 5?
Okay, you need to do long division.
So from long division, like, because if you do long division, normally you would also you do long division for x plus 2 times x plus 3.
Must I also do long division for x plus 2, x plus 3 is the divisor, lor.
So you divide it by that.
Okay, do you recall your question 6.4? Your question 6.4 of your notes?
Yeah.
So you remember that part before we start, we have to first long divide because it is not proper.
So you divide by it will be x squared plus 5x. Is it?
Just give me a second. Let me try to pull it somewhere. Okay. This one, question 6.4. Okay, so for question 6.4, if you observe, right, okay, you just notice that the top part is power degree 3, the denominator is also degree 3. So this is improper lah. Is that okay?
Yeah.
So that's why you see that a good day. Okay, so you see that it is not, you cannot start straight away. You have to long divide first.
Okay. Yeah.
So when I long divide, right, you think about this way, right? Okay, so Estebel, Aiden, when I read this, right, I'm reading this as my dividend because my dividend is being divided. I'm reading this as my divisor, right? Because fractions are always like that, the top is being divided by the bottom, right? Is that okay?
Yes. Yeah.
So if you recall how I did this, right? Okay, I just want to pull out my okay, don't mind, I got any ugly pictures, y'all don't. I took a photo of my working that day. I forgot where is it now. It's somewhere. It's gone. I cannot find it already. This one. Do you see? Okay, so first question 6.4. I don't know if you all remember this. So here, right, I have an improper fraction. You have to first expand your denominator to prep for long division. Okay? So after that, then you long divide. So you see your denominator is doing a lot of work. He has to expand first so that you can do long division. Okay, so after you long divide, then you realize that my denominator need to factorize back. So you can see my denominator is expanded to long divide, then factorize back, and the quotient is -1, which does not take part in any of the partial fraction. Whereas the remainder is being put on top, and I'm going to factorize back because I'm doing partial fraction. For the remainder, you do partial fraction, then you get the 3 steps.
Okay.
You get the idea, man?
Yeah. Thank you.
Yeah, so it's really not easy. It's really not easy. So over here, how did I get the 2x plus 5? Just to say again, it's because I really sincerely, honestly do the partial fraction. So this part, right, if I expand, is x squared plus 5x plus 6. It's a lot of dirty work. It's a lot of dirty work. You know?
Yeah, okay, yeah, can.
Can,
Thank you.
Okay, so this is question 9. Okay, so next I need to go to question 11, right? Is it 11? For both Aiden and Estelle, 11.
Yeah.
Okay, so let me go to 11. So 11, okay, question 11. I don't have the question, unfortunately, so I'm just going to use the guess the question from the answers. Okay, so x cubed plus 5x minus 9. I'm guessing that I'm supposed to do this in partial fraction now. You know? So again, I observe this is
That's correct.
an improper fraction. Improper. The power degree on top is 3. The degree on top is 3. The degree below is also 3. Improper. Right? In fact, if I compare the highest to highest, right, you can straight away see that the quotient is going to be a 1. The remainder after long division gives you something like that. It gives you x cubed minus x squared. Right? This will be your quotient. This will be your quotient. This will be your remainder. This will be your divisor. Is that okay? Is that okay?
Yeah.
And how? Then this is the part that will take part in the partial fraction. This is the part that will take part in the partial fraction. So how do I do it? Is that, okay, x squared plus 5x minus 9. Factorize this. This is like x squared, x minus 1. Okay? Now you just write it as like, okay, treat it, I mean, you can treat it either way. Treat it like a over bx squared plus cx minus 1. Because in a way, I see this like a repeated linear factor. Okay, I see this like a repeated linear factor. Okay? And then from there, you go ahead to do. I believe you all cannot, so it's just very tedious calculation. Finally, you get 4 over x plus 9 over x squared minus 3 over x minus 1. And not forget to put in your 1. Your 1 is part of the answer. Okay? So partial fraction, the trickiest one are those that are improper. Okay,
But Mr. Tan, I don't know why is it that you have to put like a over x and b over x squared is plus c x minus 1. Why cannot be a over x minus 1, then b over x and c over x squared?
Can. So irregardless of how you do it, right? You can put ABC, CBA, CAB, because ABC, they are all just dummy unknowns, right? Your A could be my C. So you see, if I do something like that, if I get A equals to 2, B equals to 3, C equals to 4, and you do something like A equals to 4, B equals to 2, C equals to 3, we could be getting the same answers, because it depends on what we choose as our denominators.
Oh, so as long, because I was scared like from the answer key, right? Like I have to put it in like a certain format. But is it as long as like you can fit the correct numbers into the improper fractions is okay, right?
Yes, it doesn't matter. So okay, maybe I just share with you. Okay, so either this is my answer, right? My A is equals to 4, B equals to 9, C equals to -3, correct? Okay,
Yeah.
so for example, Aiden would have done something different. Maybe Aiden would have done something like that. Maybe you would have done, okay, my answer is, instead of A, I want to do a different one. I want to do A over x minus 1 plus B over x plus C over x squared. So what would you have gotten? Right? You will have gotten A equals to -3. You will have gotten B equals to 4. You will have gotten C equals to 9. But you realize that whether what you and I get, we both get the same answer. We will both get the same answer.
Yeah, okay.
Right? Right? We will both get the same answer. Right? You'll get -3 over x minus 1 plus 4 over x plus 9 over x squared. See? Same. Yeah, like two twin brothers, right? They are same. Just remember to add a 1. So the coefficient, they are just dummy letters. It doesn't matter.
Okay. Okay. Thank you.
Okay, so next, let me just...
I'll be leaving now. Okay.
Okay.
Okay. Thank you, Mr. Tan.
Thank you. Okay. So next one is time break 3. Okay. Time break 3, question 6, part 1. Question 6. Question 10. Question 11B. For Estabel, time break 3. Question 4, part 2. Okay, let me go to time break 3. Wow, okay, I'm a bit tired already. Okay, so question 3, question 4. Okay. Okay. Question 4. Question 4, part 2. Part 2, huh? Is it correct? Oh no, wait. My screen very slow. My screen is like having fits. Okay. Estabel, what is bothering you for this question?
The only thing I don't know is why A can be equals to 2. Oh,
Why is A? A can be 1. Why is it A can be 1?
no, I know why A can be 1, but I don't understand why A can be like 2.
Let's see. 2A. Maybe 3 less than 4. Then if A is 3 there, then 4.5 less than 6. Why is it A can be 1? Can you explain to me your thinking process?
A can be 1 because if A is 1, then X would be 2.
If A is 1, then X will be 2. Given that X was found for which. So I solve this one. My final answer is A 1.5A X less than equals to 2A. So I need an X value. So the thing, if X is going to be between, if I divide all, that means 1.5 will be XA less than equals to 2. Am I right? So that means, right, by X over A, it must be between this value. Wow, yeah, I also don't know. Let me think. Oh, my brain stuck. Okay. A is equals to 1. So X is between 1.5 and 2. If X is between 1.5 and 2,
But then X can be equal to 2. So
if X is equals to 2, state the value of A. So if A is equals to 1, they will tell me that 1.5 between 1 and 2. That means it will tell me that X equals to 2. If A is equals to 2, then this is between 3 and 6.
oh,
It will tell me that X can be equal
wait, why is X? Oh, wait, never mind. I think I made a careless mistake. Wait, it's okay. I get it.
You got it?
Yeah, I got it.
Wait. Why is it A can be 2? I don't understand.
No, because I put 1.5 is less than or equal to X. So
okay. Okay, can. Okay, so next one. Question 第6题. Question 6, part 2, part 1. Oh, today is so productive. Very good. Today's video can be beneficial to mankind. Okay, so this one. Okay. Which part is bothering you, Erin? Part 1. Erin. Do you say something? Are you there, Erin? Erin, this is your question, right? Can Erin hear me? Is Erin looking at me? Erin, can you hear me? Oh, she's connecting to audio.
Yeah, I can hear you.
Hey, oh, wow, okay. Yeah. Oh, yeah. You mean just now I was muted to you? Or
Just now I left the audio.
you left the audio?
Yeah,
Wow, why?
because I was doing other things.
Oh, okay. Can. Okay. Wow, so I feel so fun. Okay, I talk. Okay. So this one, okay, which one is bothering you? Part 1 or part 2?
Sorry, what's this?
I slapped you lah with 2 of you.
Sorry.
On break 3, question 6.
Okay, thank you.
This
I
is the
need
person you mentioned. You
part
mentioned
1.
one. You just need to use what you did just now, the discriminant of the discriminant. You use this one, right? You find the discriminant, show that the discriminant is less than 0, right? So when you're doing this, right, you can use the discriminant of the discriminant. Actually, this one quite easy one. You do this, right? Erin, your discriminant should be negative 4p squared minus 23, right? So
Got
this,
that.
you got that, right?
Yeah.
That's always negative, huh?
Wait, but I don't understand why.
That is like so negative. Your square, right, multiply by negative number. So p square is always more than equal 0. Am I right? Anything you square cannot be
Oh yeah.
right. So if you have negative 4p square, that is so negative, right? That is like the most negative thing in the world, right? So minus 4p square minus 23 is less than negative 23, right? So this is less than 0 for sure. For sure.
Oh. Okay.
But I realize all the questions are all discriminant one. All discriminating. So, okay, question 10. Which part is bothering you?
The whole thing.
The whole thing. Okay, let's see. Okay, so if you substitute, 10a is, okay, so 10a, if you substitute a equals k equals to 0, right? You actually don't even get a quadratic equation. So
Yeah.
for 10, so 10a is okay, right? This one is
No,
okay.
I got like there's no K in the discriminant.
Yeah. Oh, no, you won't be using discriminant or because you don't even have a quadratic. Right? You just have like x plus 2. You're left with x plus 2 equals 0.
What I used to do with that?
Then x equals to negative 2. That's the root. That's the only root. X equals to minus 2 is a root. It's the only solution.
So wait, but then so I just leave it like that?
You can see that if I sub k equals to 0, right? You only have one answer, right?
Oh yeah.
So the one answer is the only one true root. So you have showed yourself that when you sub k equals to 0, you have only one root, which is x equals to -2. Also, so you see, you have done what the question asked you to do. You have showed that after you sub k equals to 0, right? Instead of a quadratic equation, it reduces to a linear equation. When you solve the linear equation, you have only one real root. Means that you only have one answer.
Oh, okay, okay.
So it's a bit, yeah, lor. You have already justified. You just need to put it in, think through it. Okay. And now, hence, find the range of values for which the equation has two distinct real roots. What does this mean is now you need to compute your discriminant. The discriminant, you should get something like 4k squared minus 4k plus 1. Do you manage to get it?
Yeah.
Now, if you factorize it, right? So if I want to have two distinct real roots, right? What does that mean?
Discriminant is more than 0.
Correct. So I need this one to be more than 0. So, actually I can factorize. This is like 2k minus 1 square. Why not? Which is actually 2k minus 1 square is something square. Right? So can I say that this is always more than or equals to 0 for all k? Can I say that? Something square is always non-negative.
Wait, I thought it's more than 0, not more than equals.
This is always more than equal to 0. So your only thing that you have to take note, right? As long as 2k minus 1 is not equal to 0, meaning your k not equals to half, then 2k minus 1 square will always be more than 0. Because if your k is equals to half, right, then this guy is going to be equals to 0. Okay, so if k equals to half, then your discriminant is equals to 0.
Oh,
So
I solve the quadratic first, then I see that root, then I say that it cannot be that.
correct. It is not so traditional, this question, but rather it tests a lot on our understanding of quadratic function. Something square cannot be negative. It will always be non-negative. Can hor?
Yeah.
Can okay. Shall I go through 10b?
Yeah.
Or do you want me to wait for you? Are you copying or anything?
Oh no, I'm done.
Okay. This graph, very simple. You draw one graph, y equals to ln x. Okay, so why is it? Because I saw this lah. Okay, I read the whole question. Just like, when you do English or what, your teacher always tell you that, you cannot just read and then you try to solve. I try to find out what fits in. I always read the whole thing first. The solution to this equation, 0.159, 3.146. I sketch two suitable graph, solve the inequality, give me my answer to 3dp. So the first thing you think about is, I will highlight the important things. I need to solve this inequality. I need to sketch two suitable graph. Okay? And the graph, probably I have these two answers. Right? So here, what I'm thinking of is I can sketch y equals to ln x, y equals to x minus 2. What say you? Possible? Possible, right? Sounds very logical, right? So I draw y equals to ln x. It looks like that. Y equals to x minus 2. Looks like that. Okay. The 2 points of intersection is 0.159. This point is 3.146. Okay. Now you want the ln x to be underneath, to be below, right? You want ln x below x minus 2. Where would that be? That will be this part here and this part here, where your ln x is underneath x minus 2. So Erin, if I can bring your attention to the screen, the part that I've so-called highlighted, this is the part where ln x is underneath x minus 2. Okay? So the answer will just be x more than 3.146 or x less than 0.159. So far, okay. Okay, Irene, I'm going to go to question 11. What is bothering you for question 11?
Part B.
B. Okay. So the ball is drawn at random and then returned to the bag. The bag is then shaken to mix the ball. So this is with replacement. The probability of drawing only red ball in all K draws is less than 0.001. So in the first draw, I want to draw a red ball. What's the probability of getting a red ball? Is it there n? Oh, suppose now n is 7. 7, 10. So the probability of getting a red ball would be 7/10. So if I want to get in K draws, right, that means I want 7/10 to the power of K to be less than 0.001. This is me, right?
Why
Getting
do you make it to the power of K?
now because we are talking about K draws, right? The first draw, I want to draw red ball. The second ball, I also want to draw red ball. The third ball, I want to draw red ball. All the way, I got K number of draws, right? Total got K draws, right? I want to draw only red ball. So 7/10 times 7/10 times 7/10. So it's to the power of K because I'm multiplying by myself 7 times. K number of times.
Also, every time it's like times that you just and you give like either n or something, you just make it to the power.
Correct. That's what I see that. Okay, you see this a lot in topic 7. This question is rather important. Then from here, to solve this, just ln both sides. 107K ln 0.001, K ln 0.7, ln 0.001, K more than ln 0.001, divide by ln 0.7. Ooh, because it's a negative number. 19.367, K is equals to 20. Because K is the number of draw, it has to be a positive integer. Any more question?
I got questions for set 5.
Practice at 5.
Yeah. Question 6D.
Question 8B. 6B. Question 6B. Practice set 5, question 6B.
Yeah.
Okay, what's bothering you with this question?
I don't even know how to start.
This one, okay, you use the sum of square formula. It's inside the, how to say, this one, right?
No, D.
D. Use the sum of square formula, difference of square. So this one, right? In one portion of the notes, right? Okay, this part here, under part 4, right? Erin, can I bring you to this part, under part 4? Use this. Page 11, use this one. So that means, right, if I have 1000x cubed minus y power 6, this is the 10x power 3 minus y square power 3. Then what you do is you think of the a cube as 10, you think of the b cube as y. That will help you. Esther left. Wow. So sad, everyone left without saying goodbye. Nowadays, 小孩子都这样。You're the most regular customer. Okay lah, so I'll stop here for today.
Okay.
Good luck.
Thank you. Bye bye.
Bye.
Why are you not leaving?
Why are you not leaving? Why would you ask me?